Okay, so you got your tests back in front of you, those of you who took them. If you've taken the retest, I haven't quite gotten that back to you yet. Most of you all have already done the REEF FRQ. I'm not going to go over the free response because we already went over it. Now, if you want to have access to the video of me going over the free response, it's not in the shared folder. I didn't post in the shared folder because actually I will now. I kept it out so that people who hadn't tested yet didn't have access to it, but I will post the free response video in the shared folder. And I'm also going to post this video in the shared folder. Okay, so if you have still on your test less than a 70, you can retest next week for a max grade of 70, like usual. Just do it sometime before school, let's say by next Wednesday, okay? Because Thursday is going to be crazy because it's going to be crazy fun night and crazy powder puff finals are on a pepper schedule, and then Friday we don't meet. So Monday, Tuesday, Wednesday next week before school, unless you're ready earlier than that, like tomorrow. But anyway, so this will be the multiple choice video, and then the free responses in there. If you haven't taken the REEF FRQ yet, that's just a couple of y'all we've talked, okay? And you'll get a chance to get points back. All right, so the retest will be the same questions as these multiple choice questions, but remember they're short answer. All right, Brady can attest to that. The free response, when you retake it, will be similar to the original one. It'll be similar to the re-FRQ we did yesterday, but it's going to be a different Ferris wheel. So the numbers are going to be different. Again, but the ideas and the question order are still the same. All right. It's the largest, it'll be the largest imaginary one. Right, right. The big kahuna, right. You've heard about it. All right, so I'm going to go through this. If you have any questions, if I go too fast or I don't address the issue that you why you missed it, just holler, right? Holler out. We'll go over it. All right. So the goal is to understand why you missed it and also to make sure I graded it correctly, right? I go fast. All right, number one, which equation describes the graph of the function above? And it's one of these multiple choice questions where you have answer choice 1, 2, 3, and then the answers are combinations of them. So the best way to do this is just to analyze each of the equations and see if it generates it, right? Because there's infinitely many equations that generate this graph. So there's a couple of things that we should figure out. First of all, they all have amplitudes of 3, right? So I'm guessing the amplitude is 3. That's not going to be something that makes it or breaks it. They all have the same B value as well, right? So the period is also going to be the same. So that's not necessarily what we have to check. They all have the same D value, right? So that's not something we have to check either, unless it says none of these. So we should check it anyway. So really it comes down to, is it the right plus or minus sine or cosine with the phase shift attached? So let's go ahead and kind of gather some information. First of all, let's go ahead and figure out the period just for kicks and giggles. Let's do it from high point to high point. That's probably easiest. How far is it from 1 pi halves to 3 pi halves? Well, it's 3 pi halves minus pi halves, right? Right minus left, big minus small. 3 minus 1 is 2 pi halves, which is pi, right? So if the period is pi, we know the B value should be 2 pi over that. 2 pi over pi is 2. All right. So yeah, indeed, the B value is 2. That's good. Let's go ahead and figure out where the sinusoidal axis is. The high point is 2. The low point is -4. There's a couple ways you can figure out the amplitude of the midpoint. What's the total distance from -4 to 2? 6, right? 2 minus -4 is 6. What's half of 6? 3. So 3 should be the amplitude. Okay, so that's good. And then to figure out the sinusoidal axis, you can either come up 3, 1, 2, 3 from the low point, or down 3, 1, 2, 3. And so the sinusoidal axis is at -1. So indeed, those numbers that we just looked at, amplitude, B value, and D, they are 3, 2, and -1. So those are all good. All right. Now, finding the period is important because it allows us to fill in the missing pieces here. If the period is 2, what's a fourth? I'm sorry, the period is pi. What's a fourth of the period? It's pi fourths, right? Why are we interested in that? That is our counting interval, right? Our quarter cycle counting interval. Not every critical value is labeled here, right? So now I can finish them. I can finish labeling them here. I drew this on the wrong spot. It's right here. So this is an access point. And where is it at? It's at 1 pi fourths, right? So I can finish labeling the 1 pi fourths, 2 pi fourths. This would be 3 pi fourths, 4 pi fourths, 5 pi fourths, et cetera, 6 pi fourths, 7 pi fourths. I can go crazy here, right? And if I go to the left, I got 0, of course, and then I get negative 1 pi fourths, negative 2 pi fourths. This is negative 3 pi fourths. I'll move it over a little bit. Negative 3 pi fourths, negative 4 pi fourths, negative 5 pi fourths, so on and so forth. So now that I have all of them labeled, remember your critical values, it's easy then to pick out what we're doing here. Let's see then if number 1 works. Number 1 is a negative cosine. Negative cosine has to start at a low point. Here's a low point, low point, low point, low point, low point. It's shifted to the right at 5 pi. Whoa, is 5 pi even on our graph? No, it's way down the line. So without extending the graph, here's what we know. We notice patterns. I have a low point at 0, a low point at 1 pi, a low point at 2 pi. The next low point should be at 3 pi, 4 pi, 5 pi, 6 pi. So I'm making this note to myself. I notice that I have lows at multiples of pi. So will I indeed have a low point at 5 pi? Yes, I will. So having a negative cosine shifted to the right at 5 pi, that's going to work, right? That's going to work. So number 1 is good. Now, what if this had been plus 5 pi? Would it also have worked? That would shift at left 5 pi. Would I have a low point at negative 5 pi as well? Yeah. So it would have worked with the plus or minus, but it was a minus. So if you know how to take tests, right? If 1 is in, you can now go through and any answer choice that doesn't have 1 in there is out. So now it's down to 1 and 3. Okay, let's look at the next one. We're doing a negative sign. Negative sign is on the axis going low. It tells us that it's shifting to the right pi fourths. So let's go to pi fourths. It's right here. At pi fourths, are we on an axis going low? Nope, it's on an axis going high. So, man, nice try, negative sign. It's not going to work. If that were positive sign, that would be good. Or if I shifted over to 5 pi fourths, I'm sorry, 3 pi fourths, then it would have worked. But 2 is out. So of the remaining ones, if it has 2 in it, it's no good. So it can't be this one, and it can't be this one. Well, I'll be a monkey's uncle. Do I even need to consider Roman numeral 3? No, there's only one answer choice left, and it has 3 in it, so I'm guessing 3 is going to work. Let's verify why. A positive sign plus 7 pi fourths means it shifted left 7 pi fourths. So let's go to negative 7 pi fourths, which is way out here. Okay, that's why I labeled it all. It's on the axis going high. Is that positive sign right there? It is, and that's what it's supposed to be. So 3 does in fact work. Okay, so it is answer choice B. B is in boy howdy. That was fun. Yeah. All right, comments, questions on that? On the retest, Brady, I didn't give you this question on the retest, did I? I gave you the same graph, but what did the question ask?
I don't remember.
Oh, you don't remember? Okay. I'll tell you what it asks. It says to write an equation of the graph above. Write an equation of the graph above. So any equation, one equation, write one equation of the graph above. There's infinitely many that are correct, so your odds are pretty good, right? Better than Tiger winning the Masters, which would be okay. Better than Tyler winning $100,000 today.
Which is not possible because I'm not.
Oh, okay.
Because you have to be 21.
Oh, that's right. That's right.
It anyway.
Yeah. Better than the odds of Tyler being 21 today.
Yeah.
Right. Now the odds of Natalia being 17 today, much better, right? Is it 17? Yeah. Okay. Yeah. Happy birthday again. Anyone else having a birthday? Do you know you share a birthday with Danny Dorito? Yeah. And Jackie Chan and Russell Crowe and the internet. That's important. Yeah, the internet was born in today, 1969. Right. So 53 years old. Yeah. All right. And it's National Burrito Day. Yeah. Opening day for baseball, Masters. It's a pretty big day. But at the top there's Natalia's birthday. All right. Anyone else in here having a birthday? We can share. Oh, and the beard tax was, yeah.
No way.
Find the period and the amplitude of the function. Find the period and the amplitude, period and the amplitude. Well, the amplitude is 4, boom, right? Easy, right in front. So it can't be amplitude of 5, can't be the amplitude of 9. So now, right now, I'm down to 50-50 if I don't know how to find the period, but I do know how to find the period. Remember, the period is 2 pi over b, 2 pi over b, 2 pi over b. Is b in this one pi-8ths? Is it always just the number in the front? No, no. It's the coefficient of x. You don't even have to factor it out. The only reason you got to factor the b out is so that your horizontal shift is correct. But the b value, whether you leave it, factored in or factored out, is still 2/3. So 2 pi divided by 2/3, right? And now we'll stay, change, flip, stay, change, flip, right? Good dog. We get 3 pi. So it's got to be B, right? It's got to be B. It's got to be B. Now, of course, it wasn't a multiple choice on the retest. So on the retest, it says, find the period and the amplitude, show your work. What kind of work do we need to show? Well, just this little calculation right here. 2 pi divided by 2/3, stay, change, flip. You don't have to show work for finding the amplitude because it's literally right there. Yeah. Okay. Comments, questions on number 2? How are we doing on time? Good? Time. Number 3, determine the range of the function where b is a positive number. We found the range every single time, right? The range, remember, is your sinusoidal axis, which is your d value, minus the amplitude to get to the low point, and then your sinusoidal axis plus the amplitude to get to your high point every time. Well, looky here. My d value is -3b/2, and my a value is b/2, which is already positive. So here's all I got to do. -3b/2 minus b/2 for the low point, and -3b/2 plus b/2 for the high point. Instead of numbers, I have numbers and letters, right? So they have already the same common denominator. You're welcome. So what is -3b minus another b? It's -4b. Let me write the intermediate step here. The intermediate step would be -4b/2, the lower bound. And what's -3b plus b?
2b.
-2b, bless you, halves, right? And then I simplified, bless you, simplify, do or die. That's the Marine Corps motto, right? Simplify, do or die, or something like that. Maybe simplify. Close enough. Always faithful, always simplify. -4/2 is -2. -2/2 is -1. So there's your answer. -2b to -b, which is answer choice D. Right. So I know y'all know how to find range, but if I throw a letter in there instead of a number, sometimes that can derail you. But it's the same. It's the same. Don't panic. Keep that lizard brain at bay. Just use that cerebral cortex. All right. Now this one here, which of the following angles, is coterminal with that? All right. Now on the retest, I said, find the coterminal angle that's within one positive rotation, which all of these coterminal angles are within one positive rotation. So how are we going to do that? Boy, this is a classic, right? This is a throwback way back to the good old days, when we were just doing 2 clues problems, right? And not graphing sinusoids. So remember how to do that. I do remember how to do that. Let's see. Okay, so I take the coefficient of pi sevens, right, which is negative 4, 5, 6, 7, 8. Ah, you like how I did that? And I divided by what? 14, twice the denominator, because it takes 14 pi sevens to go around once. Add back now the full rotations, 32, 62, which is a negative number, remultiply by the same number you divided by 14, and you get negative 10. Negative 10 pi sevens is coterminal with that, but that's not an answer choice. So I need to add one more rotation to it, which is adding another 14, and you get 4. And that's your new coefficient. So 4 pi sevens. And that is the answer. Answer choice E. E as in eggs, right? Elephant eggs. Euler. All right, so far so good. Comments, questions, quips, quotes, concerns? Yes. Well, then you got lucky, because if you divide it by 7, what you're doing is you're finding half rotations. And because it was in quadrant 1, you get to the same place, okay? But had it been in quadrant 2 or 3, you wouldn't have got the right answer. So you got lucky. We call that serendipity or fortuitous happenstance.
I had to redo my entire calculations because I accidentally divided it by 7.
Right. Fortuitous happenstance. That's a, yeah, it's a good, it means like serendipity, right? We got lucky, and it turned out, we made a mistake, but it happened. It worked to our advantage. It is the antonym of a, how do you spell this? I don't know how to even spell this. A Pyrrhic victory. Pyrrhic is somewhere spelled similar. I don't know how to, someone can look it up. But y'all know what a Pyrrhic victory is? A Pyrrhic victory is a victory that comes at a great cost. Right? We won, but we kind of lost. So, right, yeah. So kind of like the Russians, yeah, wars, right? All right. Number 5. Hey, if the function f is shown below, what's up, f? If another function, call it g, has the sinusoidal axis at 0, so no d value, and an amplitude that's twice this guy's amplitude, and a period that's half this guy's amplitude, which of the following could be the equation of this new function? Well, let's go ahead and figure out then what the amplitude and the period are of this dude, right? So for function f, the amplitude is what? Well, how do we figure that out? We have a low point at -5 and a high point at 1. Okay. The amplitude is half the distance from high to low. So how far is it from -5 to 1? 6 units, right? What's half of 6? 3. So this function f has an amplitude of 3. I'm putting f colon a equals 3. Now let's find the period. Let's measure from high to high. How far is it from 1 to 7? 6. So the period of f is 6. Okay. Now let's find g's amplitude and period. G's amplitude is twice f's. So what's twice 3? 6. And then f's or g's period is half f. So what's half 6? 3. Okay. So now that I know the period for this new function g, let's find its b value, because that's what goes in the equation. B is always 2 pi over p. So in this case, it's 2 pi over 3, which is 2 pi thirds. So all I'm looking for now is a function that has an amplitude of 6 and a b value of 2 pi thirds. And there's only one of them that has that combination. So that's really all you had to do for that one. It's kind of a silly question, but it's a bona fide question. It's legit. It's legit.
You got the right letters. It's just the H is further down.
Oh, the H is further down the line. Okay. Yeah. Thank you. Good thing for notability, right? I could just shuffle it down. Pyrrhic victory. There you go. Yeah. Yeah. So fortuitous happenstance means we weren't trying, but we won. Pyrrhic victory means we were trying and we won, but we kind of lost. I don't know if they're antonyms. All right. Letter 6. Letter 6. The graph of the function 14 cosine of 50x is how many x-intercepts from 0 to 2 pi. Man, we had this all over the worksheet, right? So here's how you do it. Think about regular old 14. Think about regular old y equals 14 cosine of x. Regular old cosine of x, okay? From 0 to 2 pi, here's 2 pi. It's going to come up here to 14. It's going to cross. It's going to come down here to negative 14. And then it's going to come back up. So how many x-intercepts do we see for regular old cosine from 0 to 2 pi? 2, right? 2. 2 of them. Now, remember that the b value says we is now going to see 50 cycles in the same span where we previously saw 1. We're compressing it by a factor of 50. So if we now see 50 cycles, and each one of those cycles has 2 x-intercepts, 2 per cycle, how many x-intercepts are we now going to see? 50 times 2, which is 100. Yep. And that's the answer. The answer is 100. 100. Yum. That didn't take long, did it? If you know what you're looking for, if you know how to do it, if you did your worksheet and you understood it. No more beard tax. Thank goodness. All right, number 7. Suppose that tangent of x is negative square root of 3 and sine of x is positive. What's cosine of x? 2 clues, anybody? 2 clues, anybody? But it's a 2 clues off the unit circle. Oh, yeah. So let's see. If tangent is negative, which 2 quadrants is tangent negative in? That's right. Quadrant 2 and 4, right? Quadrant 2 and 4. Negative x positive y, positive x negative y. And where is sine positive? 1 and 2. What's the overlapping quadrant? Quadrant 2. So I'm over here in quadrant 2. Now, I need to know what cosine is. So look at this. Just based upon that and that alone, I can eliminate 3 of the 5 answers, right? Because in quadrant 2, cosine is what? Positive or negative? It's negative. So see ya, see ya, see ya. And now it's 50-50, right? Now let's see which one it is and why. If tangent is negative square root of 3, we can actually reconstruct what it used to look like, right? Here's how we would do it. We would say, okay, negative square root of 3. Well, that's the same as negative square root of 3 over 1. Yes, yes. And tangent is y over x. Yes, yes. Now, remember, when we take tangent and cotangent off the unit circle, I told you, you ain't got to worry about the 2's in the denominators because they's going to divide out. Well, we can reconstruct it. Multiply by 1/2 over 1/2. And now you're staring at your ordered pairs. It's going to be some type of 1/2 for x, some type of square root of 3/2 for y. And because we're in quadrant 2, it's left and up, right? And so what's the cosine? It's negative 1/2. Just for kicks and giggles, what is the angle x? What angle puts us there in quadrant 2? That ordered pair is associated with 120. Yeah, 2 pi thirds, 120 degrees. 2 pi thirds, right? 120 degrees. Very good. All right, so that's all you had to do for that one. No more, no less. All right, number 8. Which of the following is equal to a sine of pi thirds times x plus 3 plus d? Well, if you look at all these, you're like, whoa, I have no idea. I'm just going to guess. Okay. Well, we had one like this on the worksheet as well. If you look at answer choice C looks the most similar. That and A. Okay. But notice C is going to be the answer because you have two negatives here, right? And remember, by symmetry, sine is what? Even or odd? Sine is odd. Sine is odd. Cosine is even. Cosine is high axis. It has y-axis symmetry. So remember, sine, we'll write this out. Sine is odd, which means that sine of negative input means negative sine of positive input, right? Opposite inputs give you opposite outputs. So we said if you have a negative b value, you don't forget about it. You do what? You bring it out front. You bring it out front. Now cosine is even. So for even functions with y-axis symmetry, cosine of negative x is the same as cosine of positive x. So for even functions like cosine, if you have a negative b value, you just forget about it. Well, this is sine. So what are we going to do with the negative that's in front of the pi? We're going to bring it out front, and there's a negative there already. And what's a negative times a negative? A positive, and that makes it match up to this. Yep. Okay, so that was it. It was just a symmetry question. Now, Brady, on the retest, you remember how I asked that one? Remember? No? It says, simplify this equation using the symmetry of sine. And I give you an equation that has a negative b value. All you got to do is bring it out front and then change whatever the sign in the front currently is. Okay. All right. If I gave you a cosine one though, and I gave you a negative b value, what do you do to simplify it? Forget about it. Just rewrite it without it. Okay, good. Number nine. Determine the phase shift. That's the horizontal shift of the function. Okay. All right. So if you preview your answer choices, we're not interested in like plus or minus a number. It's the magnitude and then left or right, left or right. So we take a look at it and it's 2 pi minus 2/3 x. So we got to put it in standard transformation form. Now this time, Daniel, we do have to factor out the b value because we're after the phase shift, right? So the first thing I'm going to do is I'm just going to focus on this piece here. So I'm going to put that as negative 2/3 x plus 2 pi. I'm going to do that first. I'm going to put the x term first, and I'm going to kick the x out of the numerator and put it onto the side. Now I got to factor out from both terms a what? A negative 2/3. And that's going to leave me x plus or minus something, something. Now, when I factor a negative out of a positive, what's that going to do to the SIGN sign? It should change it to negative, right? So if I'm not sure what that number is, I know it's going to be a negative here, which means I'm going to have to shift my graph what? Left or right? Opposite of what it appears. So I'm going to have to shift it right some amount. So can I get rid of some of these? Left, left, left. What's left after we get rid of the lefts? Well, the right one and another one that's not right, but it's not left either. Okay, eeny, meeny, miny, mo, I choose A. I'm a lucky guesser. No, let's see why. Let's see why. Factoring out is dividing out. Factoring out is dividing out. Factoring out is the same as dividing out. So if I am going to factor out a negative 2/3 from 2 pi, that's the same as 2 pi divided by factoring out a negative 2/3. And now stay, change, flip, right? And then those divide out and we multiply straight across and we get negative 3 pi. So there it is. There it is. Whoop, there it is. Whoop, there it is. Who let the dogs out? Whoop, there it is. That's a mashup. Number 10, last one, kind of sad. For the function f of x equals this, how many cycles are there from 0 to 2 pi? How many cycles are there from 0 to 2 pi? The number of cycles from 0 to 2 pi. We can get that directly from the equation, can't we? What letter in the equation, A, B, C, or D, gives us this information directly? B. This is the B value. This is just asking for the B value. That's it. Really, it's the absolute value because, right, we don't want to list it as a negative value, but it's just the B value, which is just the coefficient of X. So you come over here to your equation and is it 2 pi fifths that's in front? No. The number in front of X is negative 2 pi sevenths. So what's the magnitude or the absolute value of negative 2 pi sevenths? Positive 2 pi sevenths. And the answer is E as in excellent. Excellent. That's like a Simpsons thing, I think, right? Yeah. There were a lot of E's on here, weren't there? And if you've noticed historically this entire year, we don't have a lot of E's as correct answer choices on our test. So if you were guessing, you're probably like, Mr. Corby doesn't like to put E's for answers, but I did have a lot of E's as answers here. So anyway, there they are. Here they were again in order. B, B, D, E, A, E, E, C, A, E. There's all 10 of them. Your questions on the retest, which if you made below a 70 next week, Monday, Tuesday, or Wednesday before school, same questions, but short answer. Show your work, and then the free response is going to be the largest imaginary Ferris wheel, the big kahuna. Same sequence of questions, just different numbers, okay? All right. There's 8 minutes left to finish celebrating Burrito Day together. Are there any questions or comments? I don't know the new schedule. What time do we leave?
It's an hour per class period.
Oh, we actually have 20 minutes left because we're on the modified schedule today. Okay. All right. Well, I'm signing out then. Bye.